Hello, everyone. A very warm welcome to each one of you on this second day of the ground classes of drone pilot training course. And today we shall be starting with the sixth chapter of the course, which is about weather and meteorology. Yes, weather and meteorology are critical factors in aviation as they can affect the flight performance as well as the safety. Every pilot must have a very good understanding of the weather patterns and how these weather patterns can affect their flight. Weather forecasts are always used by the pilots to plan their flights. In this chapter, we will look into every key aspect in detail. So let's begin up with this session. First of all, we shall introduce ourselves with the definition of a weather. Weather refers to the state of the atmosphere at a particular time and place. It is affected by several factors such as the temperature, the air pressure, moisture in the air, that is humidity, the wind speed, and precipitation. The weather patterns can vary to a very large extent depending upon the location as well as the time throughout the year. They can have a very, very significant impact on all our lives. Weather forecasts use the data from a variety of sources such as satellites, weather radar, ground-based weather stations, and these data helps to predict the weather patterns that may prevail in the future. These forecasts are very essential for not only to the aviation sector but also the other industries as well, such as in case of agriculture, weather plays a very important role. We all know how the quality of the crops is dependent upon the rain, and this rain, sun rays, windy days, these all are a part of weather. Now we shall introduce ourselves with the term meteorology. What is meteorology? Meteorology is the scientific study of the Earth's atmosphere and the processes which cause the different weather patterns. This meteorology focuses on various atmospheric variables. For example, it focuses upon the temperature and how the temperature varies throughout the atmosphere. Similarly, it tracks and develops the analytics on how the pressure varies through the atmosphere, how the density varies, and how does it affects the various other dependent parameters. In India, there is an IMD department. The full form of IMD is India Meteorological Department. This is a national agency responsible for all the matters which are related to the provision of meteorological support to aviation industry in India. Meteorology is very important for aviation because of various reasons. Number one is the safety. Adverse weather conditions such as thunderstorms, ice, turbulence in the air, and strong directionless winds can pose a significant risk on aircraft's operation, as well as if it is a manned aircraft, then to the passengers as well. It affects the efficiency. Meteorological information is very important for the pilots to optimize their flight paths. By optimizing the flight paths, by optimizing their cruising speed, they can minimize the fuel burn and maximize their range and endurance of their airplanes. This is why meteorological information is important from airplane performance perspective as well. I already said flight planning. It helps the pilots to plan their flight paths. The data which meteorological organizations provides helps the flight to operate safely. Let us talk about the standard atmosphere now. We have heard about the Earth atmosphere, right? We know our Earth atmosphere has several layers, which are troposphere, stratosphere, mesosphere, thermosphere, and that exosphere. These layers of Earth's atmosphere do not have very sharp or specific boundaries, but they have some approximate altitudes that can separate the one layer from the other. But you will not observe any sharp boundaries separating the atmospheric layers. Every atmospheric layer, either it is the troposphere, which is very close to ground, or it is stratosphere or mesosphere or thermosphere, every layer of atmosphere actually gradually merges into the other, and every layer has its own characteristics that, with respect to the atmospheric variables, atmospheric air properties. The atmosphere of the Earth is very dynamic in its nature. The air properties not only varies from season to season, but they vary from day to day. And even throughout the day, you will find that the weather changes from place to place, and this affects the performance of the aircrafts. So it is very important because any aircraft, whether it is a drone or a manned aircraft like aeroplanes, they all have to operate in the Earth's atmosphere. So it becomes important that the performance of the airplanes should be able to accurately obtained and estimated during the design process. So because of that, this dynamic nature of the Earth's atmosphere, the aerodynamicists in the historical period of time, they have decided to establish an international standard atmosphere model, and that international model of the Earth's atmosphere gives that atmospheric air properties values to the designers around the globe as a reference, as a common reference, which any designer can refer. Even pilots also use those international standard atmosphere air properties value to know, to understand at which altitude they are actually flying. The International Standard Atmosphere, which was developed, was named as ISA, and it can be defined as a static atmospheric model of how the pressure, temperature, and density of the Earth's atmosphere change over a range of altitudes. It has been established to provide a common reference for temperature and pressure and consists of tables of values at various altitudes. There are some formulas by which these values can be derived or calculated. You can see on the screen there is a chart that shows how the temperature of the atmosphere, Earth's atmosphere, varies with altitudes. At sea level, the temperature is around 15 degrees Celsius. In Kelvin, it is 280. It is almost 288 Kelvin, and we can see the behavior of the temperature as we go up into the atmosphere. The temperature reduces from sea level valley. The temperature, reduces from the sea level valley to a value of almost minus 50 or 53 degrees Celsius, up to a height of, let's say, 11 kilometer. After that, this temperature stays with a constant value to almost, let's say, 20 kilometer of altitude, and then the temperature rises from 20 again and reaches a value which is again close to the value which was at sea level, 0 kilometer altitude. Again it stays constant up to some kilometer of height. Again it decreases, and this time it decreases to about minus 80 degrees Celsius till the height of, let's say, 90 kilometer altitude. Then again it holds at a constant value, and again it rises. So we can just observe from this graph that temperature throughout the atmospheric layers of the Earth is changing a lot. At the very beginning, close to sea level, when we are going up and getting the height. The observation was that temperature was falling. Then it stays constant. Then it again rises to some altitude of about 50 kilometer at. Then again it is constant. Then again it goes towards the negative value. This dynamic nature of the temperature throughout the Earth's atmosphere influences the value of pressure as well as density, because we know P is equals to rho RT. So if temperature is affected, the pressure and in turn the density and everything is going to get affected. Okay, and because of this, different values of temperature, pressure, and density exist through the different altitudes of atmosphere, and this influences the performance of the flight, like range of the aircraft, endurance of the aircraft, the maximum velocity of the aircraft, the rate of climb of the aircraft, landing performance, takeoff performance, everything is affected because of the change in the values of these atmospheric properties. So this is why it becomes important to understand the international standard atmosphere model. Okay, so there were certain experiments which were done in the historical period, and some experimental balloons were lifted, and some experimental rockets were launched, which were occupied with some sensors. They goes up through the different layers of atmosphere, and they measures the pressure, temperature, and density, and sends the data to the ground so that it can be tabulated. And this all experiments have made this development of international standard atmosphere possible. And later on, based upon some theoretical formulas, some fundamental, it became possible to develop a formula, a direct formula that can give you the value of pressure, temperature, intensity throughout the different altitudes. Measuring the air pressure. Measuring air pressure. A barometer is used to measure the atmospheric pressure, and that pressure measured by the barometer is also called as barometric pressure. Changes in the air pressure of the Earth's atmosphere affects the weather, and meteorologists use barometers to predict short-term changes in the weather. Barometer is a device which consists of a glass tube inverted into a dish containing mercury, and when the atmospheric air having some pressure, which is a static pressure, comes into the contact with the dish containing the mercury, the atmospheric air exerts some pressure on the mercury, and this mercury travels inside the inverted glass tube. The height of the mercury inside the glass tube gives you the value of the atmospheric pressure. So this is how a barometer works. What do you understand by heat and temperature? Heat can be understood as the energy that is transferred from one body to the another as a result of difference in the temperature. It is measured in calories or joules. Temperature is a physical quantity that expresses the degree of hotness or the coldness of any body or substance. Temperature is measured by an instrument known as thermometer. These days, digital thermometers have gained some popularity, and they use electronic sensors to measure the temperature. Okay, the wind also influences the weather. How can we define that? The large-scale flow of atmospheric air is called wind. The main reason for the wind to flow is the difference in the atmospheric air pressure between two regions. Wind can significantly affect the performance and safety of flights, such as headwinds and tailwinds. Yes, headwinds are those winds which can be understood as appearing towards the aircraft when aircraft is moving forward. So it is basically the headwind is the wind which is moving from the nose of the aircraft towards the tail. Okay. So whenever aircraft encounters any region of the atmosphere where the headwind is coming, so it affects the performance of that aircraft, because headwinds gives the aircraft's way an opportunity to develop sufficient amount of lift, even at when it is flying at low speeds. So during takeoff and landing, when aircraft is not flying at very high speed, there is a sufficient amount of lift on the wings, and therefore aircraft needs a shorter runway for takeoff or for landing. Okay. In contrast to this, there is a tailwind, and tailwind any aircraft may encounter while passing through a region of the atmosphere when the wind is blowing from the tail towards the nose of the aircraft. And this type of wind is not good for during the takeoff and landing. Okay. There are some crosswinds, and crosswinds are very, very dangerous because they can severely take the aircraft out of the runway. So this is how the wind affects the performance of the aircraft. Let's talk about the moisture and cloud formation. Moisture refers to the presence of water in the atmosphere, and humidity term. You have heard this many times. The humidity is the measure of the amount of moisture. It is the measure of the amount of moisture which is present in the air. Okay. Now, before we go on understanding how the cloud formation takes place, it is important to understand the term condensation. Now, what happens when the water evaporates from the water bodies like sea, oceans, rivers, lakes, ponds? What happens is the air, atmospheric air, absorbs the water vapor as a moisture, and it goes up because the air is warm, so it moves up into the atmosphere. And as it moves up, it starts to cool down. Now, the atmospheric air will have some capacity to hold this moisture within itself. So what happens? As it cools down, while traversing upwards, it reaches a point where the air can no longer hold this moisture, and then the water vapor condenses into the tiny water droplets, which results into the formation of clouds or a fog. So if the temperature is low enough, the moisture can freeze and form snow or ice particles as well. This is how a snow or ice formation also takes place within the clouds. So now you can understand that our cloud is basically a mass of innumerable tiny water droplets, or you can say the ice particles may also be, or a mixture of both, which are suspended in the Earth's atmosphere, much above the ground surface. Clouds formed when water condenses in the sky. That is what we call here as condensation. Clouds are visible indicators of atmospheric processes. It provides clues, hints on what activities are about to take place in the near future by observing the general weather patterns. For flight planning purposes, the visibility and cloud heights are reported by the meteorological sources. Formation of clouds can be now very nicely understood, and on the screen we have some very concise key points that describes the process involved when the clouds are forming. Evaporation of water into the atmosphere in the form of vapor. Now this hot air rises up and continues to cool down. After reaching a condensation level where an air could no more hold the moisture in it, the vapor changes itself into the water droplets or ice crystals. This is basically referred to as cloud formation due to condensation. Thus, the cloud is condensation, and the condensation means vapor is changing itself into water droplets or ice crystals. There is one important point to note here. Where this water vapor will convert into water and where it will convert into ice, because there could be a possibility that cloud may contain ice particles as well. So there is a dew point. If that dew point, which is basically temperature, you can say, if that dew point during condensation is greater than 0 degrees Celsius, the vapor will convert into the water, and if it is less than 0 degrees Celsius, it will convert into ice crystals. Okay. Classification of clouds. Clouds can be classified based on the height at which they are present in the Earth's atmosphere, and also by their appearance, how they look. There are some clouds which are known as high clouds. The clouds which are present in the altitude that has a range between, let's say, 20,000 feet to 40,000 feet above the ground. Those clouds which are present in this range are known as cirrus clouds or high clouds. There is a second classification of the clouds which are known as alto clouds. These clouds are also known as middle clouds, as they can be easily seen to be located at an altitude in the range of 7,000 feet to 20,000 feet above the Earth's atmosphere. And the third category is the low clouds. The low clouds are also known as stratus clouds. These stratus clouds appears like a sheet or a very flat surface kind of thing. These stratus clouds can be seen within the 7,000 feet above the ground surface. The fourth classification of the clouds are clouds which have a vertical extent. These clouds are also known as cumulus clouds. The clouds which have some vertical extension along with some base, referred as cumulus, and they can be seen from in the Earth's atmosphere even at a very low altitude of, let's say, 2,000 feet to a altitude of around 30,000 feet as well. We can see in this image, we have a high clouds which are known as cirrus. Cirrus can be seen here. They are of feathery nature, okay? They appears to be like silky, and these cirrus clouds just below 7,000 meters, there are alto clouds, and you may be able to see on this, we have some clouds with a name cirrostratus or a cirrocumulus, or maybe altocumulus or altostratus or a stratocumulus or cumulus strat. So these are again the same high, mid and low clouds only, but when they mixes up with the cumulus clouds, they are named this way because then they have a property of their own as well as the property of cumulus clouds as well. Alto clouds do not have any particular shape as cirrus, which looks like feathery in its nature, and hair-like kind of structure. Alto clouds, when mixes up with the alto clouds, can be remembered to be the clouds which are present in the mid altitudes, and when they joins with the cumulus clouds, they may have developed some puffy kind of structure, and these alto clouds may sometimes also mix with the stratus, and then they forms a flat sheet in the sky. And the third type of cloud is stratus, which are the low clouds, can also be seen in this image. Cumulus clouds, I was telling, the clouds that has a vertical development or a vertical extension, and these cumulus clouds are responsible for a very threatening, sometimes very dangerous weather conditions like thunder lightnings. There are some common prefix or suffix which you may sometimes see along with the name of the general names of the clouds, which are cirrus clouds, alto clouds, or stratus clouds. We can see here we have altocumulus. As I was telling, altocumulus is the alto clouds, but when they have joined with the cumulus clouds, they have formed some patches like cloudlets, and then they appear similar to as shown in the figure. Cirrus clouds peaks can be seen here. Altocumulus is also shown here. Stratus clouds, I was telling, it is a flat, layered types of clouds which will not have any vertical extension, but they will be just like flat, covering the entire sky, and they stops the visibility of the sky also. And there are some nimbus clouds as well. Nimbus clouds are those clouds which are responsible for raining. Okay, so we can see how the different shapes of clouds are present in the sky, and each type of clouds refers to a particular condition of the weather. Okay, this picture is shown here, giving us the details of the properties of each of the clouds. Like we can see here, we have a detail in the picture showing different types of clouds with their properties. We can see the cirrocumulus clouds looks like cotton, and they may produce a light turbulence. Similarly, There are some stratus clouds which are very stable in air. They are located near the surface and they restrict the visibility. Then we have stratocumulus clouds, which are puffy clouds and forms meteor. Meteor is a term which stands for, is an abbreviation actually, stands for Meteorological Terminal Aviation Routine Weather Report, or it can also be understood as Meteorological Aerodrome Report. It is a standard international format for reporting the current weather information. METARs are issued on a regularly scheduled basis unless significant weather changes have occurred. A METAR weather report is predominantly used by the pilots and they are the part of a pre-flight weather briefing. METARs typically comes from the airports or permanent weather observation stations like IMD departments. A typical METAR report contains the following data. It contains the station for which the weather is being reported, date and time of issue. It contains the data about wind directions and speed. It tells us about prevailing visibility in the atmosphere, how much amount of cloud cover throughout the altitude is present, what is the temperature and the dew point. It also tells us about the pressure and altimeter setting at which the pressure is recorded, and it gives us the trend. So we have an example before us which will help us to understand how to read the METAR report from these weather stations. On the screen, we have an example of METAR from Rajiv Gandhi International Airport in Hyderabad. This METAR report was taken on 11th February 2023 at 7:30 UTC. UTC means Coordinated Universal Time. We can see we have written METAR VOHS 110730Z 04006 KT, then 6000 NSC 33/05 Q1017 NOSIC equals to. So this is the METAR report format, and let's decode it so that we can understand about the weather at Hyderabad airport on 11th February 2023 at 7:30 UTC. This term METAR indicates that following is a standard hourly observation. Okay. Now VOHS, what is that? This is actually a station code because it is recorded for ICA airport, which is Rajiv Gandhi International Airport, Hyderabad. So in the list of ICAO, the code which is airport code which is allotted to Rajiv Gandhi International Airport is VOHS. Then we have 110730Z. This thing indicates the day and time of the observation. It is the 11th day of the month. It is equal to the 7:30 AM Greenwich Mean Time, or you can say 1300 local Indian Standard Time. Then we have 040 and 06. These digits refers to 040 indicates the direction of the wind is 40 degree and 06 KT indicates the speed of the wind is 6 knots. Then we have 6000 written in after KT. 6000 indicates the prevailing visibility is 6,000 meters, around 6, which is 6 kilometers. Then NSC indicates no nil significant cloud, that is none below 5,000 feet, and no towering cumulus or cumulonimbus clouds present. 33/05, this digit refers to the temperature, which is 33 degrees Celsius, and the dew point is 5 degrees Celsius. And if written in front of the number, will indicate that the temperature or the dew point is below the 0 degrees Celsius. Then Q1017. This indicates the current altimeter setting, which is in QNH. QNH means the pressure recorded is with respect to the mean sea level pressure, and it is 1017 HPA, that is hectopascal. Then it is written NOSIC, NOSIG. NOSIC is an example of a trend forecast, which is appended to METARs at stations while a forecaster is on watch. NOSIG means that no significant change is expected to the reported conditions within the next 2 hours. And last, which is an equals to sun. This indicates the end of the meteor report. I hope now you all know how to read or decode the meteor data, which publishes hourly or from time to time by the weather or meteorological departments. And with this, we complete the sixth chapter, which was weather and meteorology. Thank you.